This is physics for class 12. Here the question is a thin plate rod is bent into a circular ring of radius r. It is uniformly charged with charge density lambda, the magnitude of the electric field at its center. So the theory here is that for any small element dq, for any small element dq, there is an equal and opposite charge, that is minus dq. There is equal and opposite charge element minus dq on the other side of the ring. If it is dq, for any small element dq, there is an uh, equal and opposite charge, uh, uh, plus. So here this is plus. So equal and opposite charge. Yes, equal and opposite charge will be developed on the other side of the ring. On the other side of the ring for any small element. For any small element dq on the opposite side. Uh, uh, a, a charge element dq equal and opposite charge element dq will be present here. Oh, sorry. That means 1 minute. Sorry. That is, it is uniformly charged. It is uniformly charged with charge density lambda. So for there will be an equal and opposite for any small element dq. There will be an uh, equal charge on the opposite side of this ring dq. So again for here there will be dq because this whole ring is uniformly charged. Because this whole ring is uniformly charged. Since it is uniformly charged for any element dq, there will be and on the opposite side of this ring there will be a charge dq. It will be present here for any charge. Here there will be a charge dq on the opposite side of the ring. So as a result, the magnetic field at the center will be zero. As a result, the magnetic field at the center will be zero. I think so it is clear for you because it is uniformly charged. So for any element here you say dq, there will be another same charge dq present on the opposite side of the ring. And so the magnetic field at this will be zero. Magnetic field at the center will be zero. Here you see 10 capacitors, each of capacitance 1 microfarad are connected in parallel to a source of 100 volt. Total energy stored in the system. Here capacitance, it is given 1 microfarad, that is equal to 1 into 10 to the power of minus 6 farad. And since there are 10 capacitors and they are connected in parallel, so your total capacitance will be how much? 10 into 10 to the power of minus 6 farad. So this will be 10 to the power of minus 5 farad. And your energy, that will be half CV square. So this is half 10 to the power of minus 5 into V is your 100. So this will be half uh, CV square. So this is double zero. So this will be into 10 to the power of minus 1. So this comes a minus 5 into 10 to the power of minus 1 joules. So this is your answer. capacitance is 1 microfarad, so 1 into 10 to the power of minus 6 farad, and total capacitance will be, because there are 10 capacitance and they are connected in parallel, so they sum up, and this sum up will be 10 into this, 10 to the power of minus 5 farad, and your energy formula is half CV square, so half capacitance, so this becomes this much joules. And the next question is, consider the circuit shown in the figure. The potential difference between points A and B, it is given to the circuit is given to you. You have to find the potential difference between points A and B. So you all know that your E equivalent, that is equal to E1 by R1 uh, epsilon epsilon 2 by R2 divided by 1 by R1 plus 1 by R2. You know about it. So I'm going to place the value of this only here. That is 12 by 1 plus 6 by 0.5 by R1, that is 1 by 1 plus 1 by 0.5. So this comes out to be, that is 12. That means 0.5 means 1 by 2, that means plus 12, and 1, 0.1 by 2, that is 3. So this is how much? 24 by 4. 0.5, that means 1 by 2, 1 by 2. So 1 by 2. Sorry. This is 2. So 3. So it comes out to be 8 volt. Your answer is 8 volt. You know, here this is the internal resistance. This is the internal resistance. So E equivalent, that is epsilon 1 by R1 plus epsilon by R2, 1 by R1 plus R2. And this is here you see it is in parallel connection. This is in parallel connection. So as it is in parallel connection, so this is the E equivalent, that is the potential difference between the points A and B. The next question is, a 10 centimeter long wire carries along y-axis it carries a current of 1 ampere in positive y direction. The magnitude of magnetic field is given to you, exists in the region. The force on the wire, you know the formula, I L cross B, you know this formula. Here I is 1 ampere and L is this is it carries a current, oh sorry, uh, 1 ampere in positive y direction. So positive y direction, that is 1 J cap, and L is one thing here. Here you have learned about that. In this theory, you have learned that since I is a scalar quantity, so length has been considered as a vector quantity. So I will be 1 and your length will be 10 centimeter, that means 0.1 J cap, and the magnetic field it is given to you. This is your magnetic field, it is given to you. This is given to you. You must remember that in this formula here, I is a scalar quantity, so length has been considered as a vector, and so I 1 ampere, this is 1 ampere, and your length it has been considered as vector, so length is 10 centimeter, that is 0.1 meter along y axis, that is J cap, and this is your magnetic field. So your result will be, see, J cross J, it will be 0. So the result will be here minus 0.8 uh, J cross K. So you know that J K. J cross K will be I. So this will be I cap. So this is your answer. So the here formula is I hmm, IG is equal to I minus IGS. This is your formula. Here the question, you see that a galvanometer of resistance G ohms is connected into an ammeter, and we know galvanometer of resistance is converted into an ammeter of range 0 to 1 ampere if the current through the galvanometer is 0.1 of 1 ampere, the resistance of the ammeter. We know that for a galvanometer to make an ammeter, we use shunt resistance. That shunt resistance is a very low resistance, and it is connected in parallel, and this is connected in parallel. So the current through the galvanometer is 0.1% of 1. This is 1 ampere. G, that is the resistance of the galvanometer, and here current is 1 ampere current, and your Ig current is 0.1% of 1 into shunt resistance. So 0.1 by 100, 0.1 by 100, that means 0.1 by 100, that means this is 1 by 1000. So this is 0.001. So this is 0.001 G, and 1.000, 0.001, this will be 999. So this will be 0.999 S. So here, uh, so now, but we have to find the resistance of the ammeter. We know that your shunt resistance, it is connected in parallel with the galvanometer to make it an ammeter. So the resistance of the ammeter, since it is parallel, so the resistance of the ammeter will be Gs by G plus S, because you know that uh, 1 by G plus 1 by S, so 1 by R. So Gs is equal to S plus G, so R will be Gs by S plus G. You know this. So that this will be the resistance of the ammeter. Now from here, what do we get from here? We get that is G is equal to 0.999 S by 0.001. So this will be how much? G equal 999 S. So G by 999, this will be your S. Now you put the value here, that is G into G by 999 by G plus G by 99. This is G 9. So here you see this 99 cancels out, and this will be 1000. So your answer will be G by 1000. So this is your resistance of the ammeter. Now the question is the reactance uh, capacitor of capacitance uh, that means reactance of a capacitor of a capacitance C connected to an AC source of frequency omega is X. That is, you know that X is equal to 1 by omega C. Now here the capacitance is doubled, so and the frequency is and the frequency of the tripled. So your X dash will be frequency is tripled and capacitance is doubled. So this will be 1 by 6 omega C. So 1 by omega C is X. So this will be X by 6. This is your answer. So according to Maxwell equation, Maxwell's according to Maxwell, displacement current, there is displacement current if there is time varying electric field, means dE by dt, if there is time varying electric field. There is displacement current when there is a time varying electric field. So time varying electric field is present only in region 1. Here you see. The time varying electric field is present only in region 1, in this region. In 2, 3 and 4 there is no time. So your answer will be region 1. This is the important point. According to Maxwell, displacement current, there is displacement current where there is time varying electric field, means this must not be equal to 0. This must not be equal to 0. And there the displacement current exists. So here only your displacement, there is a time varying electric field. So your reason 1 will be your answer.